Okay, so this is the third video of this kind of tutorial of SolidWorks and 3D printing. Jarek is still here. I just wanted to kind of break these up to more defined videos and stuff. So any thoughts about how hard you think flow simulation is, Jarek?
I've never done it before. I've seen other people do similar stuff, but I've never done it personally.
It is probably the most simplest thing you can do if you actually know each piece. It is so simple. But so we're gonna open up this top piece right here, and we actually have to make a lid for both of these entrance and exit holes. So making a lid is just basically making a unmerged portion of this mold, and so you can see it, and it'll make sense. So I'm going to if you also if you just click, it'll show up your history, like where it's at. So this is a mirror, so I can't actually go back into the sketch for this right here. So I'm gonna have to do plane, so a reference plane on that circle. You can see it, it's right there. And now I'm gonna sketch on that circle a perimeter circle. And then the perimeter circles are sometimes annoying. Oh, got it in the first try. There we go. Anyways, okay. So now we're going to do a box. What is that?
Is that circle directly the same dimension of the injection circle that you made previously?
Yeah. So let me do that again. But okay, yeah. Let me just do that again. So we have our plane right here that is on this injection mold, and if you can see, it's highlighting when I kind of hover over it. So if I do a sketch for a perimeter circle, that means you have to touch it 3 times.
Okay.
Yeah. So 1, 2, and the third time is going to be it's going to wrap it all the way around, and then that is what's finicky. And sometimes you miss, but there we go. 2 times in a row. There we go. So now it is highlighted, and now you can do an extruded boss base. And this isn't going to be on the final print. This is just for flow simulation. So I do 0.1 millimeters. You want to make it as small as you possibly can, like that, 0.1 millimeters. Like, you see that? How thin it is. And you're going to unclick merge result. So then it kind of shows up as not, so it doesn't look like it's a part of this mold. It's its own thing. So then we're gonna do the same thing for this exit air hole, but this time you can just press it. You can see where it's at. Cut extrude 7. So I'm going to go to cut extrude 7. I'm going to go down to a sketch, and it highlights our sketch for us. And then I'm going to go to extruded boss base again. And I'm going to go backwards. There we go. 0.1 millimeters. And then unclick merge results, uncheckbox it. Now we have an unmerged portion of our lids. So does that make sense?
Yep.
Okay, and I like to actually rename these for like in lid, and then I do out lid, because then you can kind of hide them. So then we go back to our assembly. It's going to ask if, since we changed some of the models in the assembly, we're going to select yes. So now it shows that these lids are on. So now we can start our flow simulation. If you don't have flow simulation on your computer, I think you just go down to insert, and then there's a way you can also just look it up. I don't exactly remember. Applications, and maybe.
Is it something like, so when I downloaded SolidWorks from like the MyASU apps, that flow simulation was within that download? Like I don't have to download anything else?
You might have to go back in and re-download and download
Okay.
the flow simulation aspect of it. But when you do download, just initially, if you're looking into doing this, for anyone else, because I think you already have SolidWorks on your computer.
Yeah.
But if you're just now downloading it, then you can just check the box for that you want the flow simulation package. So it's pretty cool.
Okay.
Yeah, so we're gonna now go into flow simulation, and I'm just gonna click that. So I'm telling you, this is the easiest thing you're probably gonna do in SolidWorks. Go to Wizard. You're gonna name our project, and we're gonna do 2 mm spiral fluid flow. Oh, let's press enter. Okay. We're going to keep it in our SI units. So like, all our pressures and pascals, velocity, all that kind of stuff. So you just press next. We're going to have gravity in the, as you can see, there's a Z direction here. It's at -9.8, which means that we're going to have gravity going up. So I'm going to double click this and actually delete the minus sign, since gravity is actually going with our positive Z direction. I don't know, that just depends on how you make it. So sometimes it's different. So does that make sense? Okay. Yeah. Okay. So I'm just gonna, you can do anything you really want. I only just keep the gravity. You can change other things, but these are like heat conductions and radiations and stuff, rotations, like which we don't even have. So, and then you pick your liquids. So when we have hydrogels, right now we're testing 3 types. You want to go into new. Sorry, I keep on burping for some reason. When you want to go into new materials, and then we can go into liquids, and we can make our own. So predefined is ones that are already made, like these ones. User defined is us doing it ourselves. So we can make one ourselves if you go to File, New, and doing that. But I'm not going to do that because I don't have any numbers with me right now. So I'm actually just going to do a non-Newtonian liquid with blood, and then I'm going to double click blood so it loads in here. Flow type, so it's a laminar flow. Pretty sure that's the only thing you can pick anyways. So we'll keep it that way. You can change the roughness of these walls. I have, again, no numbers of these injection molds, but we also, these are kind of preliminary numbers. You just want to know if this mold will kind of have a kind of sufficient flow throughout. So you really don't need any of this stuff. Adiabatic wall, again, like we're not working with heat or anything. So slip conditions, you can press it if you want, but it really doesn't matter. Again, some more parameters, units and stuff. Not going to worry about it. Finish. So now we have our computational domain, which is this black box right here. Now it's basically telling us, all right, this is where it's going to go. This is where all the fluid flow is going to happen, is in this injection port now. So I have this air hole. So we actually don't need that anymore. I mean, it's still going to be there, but we're just going to hide it because it's annoying if it's still there. And now we're going to put in boundary conditions. You're a sophomore. You haven't even touched transport yet, right? Yeah. Oh. So you're going to learn more about boundary conditions and stuff when you take the transport class. But basically, boundary conditions is like what are like initial values, or like what can you get up to, like values type of things. It's hard to explain, but I basically will select for our inlet mass flow. I'm going to keep it selected for inlet mass flow. So the mass is going into the mold. I'm going to right click on this lid, and I'm going to go to select other. And I'm actually going to do the face on the inside of the lid. See how it's selected on that inside portion?
Yeah.
Not that. And so we still have inlet mass flow picked. When I do these blood ones, I do 0.01 kilograms per second. There's no specific reason, but right now, just because of time and everything, I'm just going to keep it simple. So that's okay. So that's our inlet mass flow boundary condition. As you can see, we have it going inwards with those arrows that are showing. Okay. So we're going to do another boundary condition with our static pressure, and our selection again is going to be a selecting other and that inside portion of the lid. Don't really have to change anything. If you want, again, do what you want, any type of numbers or anything, but we'll keep it on that. Any questions before I move on?
Is that direction on the airport you made? I just can't really see. Is that the arrows going inside or outside, or what type of arrows? I can't really see. The blue ones.
Yeah, so this is pressure. It's going to be going. So if I wanted to do another flow, mass flow out, I don't even think it would work because it would be on the inside, unless it be negative. I don't know. This is what I know. The pressure. Okay. I know it works.
It's the most important part.
What?
That's the most important part.
Yeah. Don't ask any questions. How about that? I'm just kidding. I'm like I said, I'm not an expert at this. I watch a lot of YouTube for how to do these things, and it makes sense. So, so now we're ready to run. Our results are not loaded because we actually haven't solved this solver. And so I'm gonna hit run. I'm gonna run it on this computer. You can run it wherever you want. I don't have anywhere else to run it. So before I do this, I hope Zoom doesn't crash. I'm going to actually take off my PowerPoint to a snipping tool and any other things I can delete. Close, hold on a second. I don't want it to crash while I'm on Zoom. So, yeah, here we go. And yeah, I'm going to actually take that piece off too. Yes. Okay. Please don't crash. That's all I'm asking. Run, run. And here we go. So now it's preparing the model. It's going to go through a bunch of different calculations to properly define this. I don't know if you can hear my computer, but it is blowing air like crazy. So it's also working pretty fast. Sometimes it depends on the model that you use. Like if you have a super complex one, like my blood vessel one, I think it took maybe 5 to 10 minutes to properly calculate, but this is such a simple thing that it works. Cool, it's done. There we go, didn't crash. And this is the solver. A lot of, like, these are things that, you know, if you want to look at, you can. Basically shows you all timing and stuff and the type of cells that are, and it gives you warnings sometimes if you do it wrong, but you don't even need that anymore. So now the results are loaded. You press the plus button. There's so many different things you can do. You can export all these values, but let me just show you how to just kind of, you can physically see the flow working. So I'm going to do, again, our select other face. Where is that back face? There it is. And then these are how many points that are going to be on that face itself. I like to do 50. You can do as many as you want, as little as you want. The more the merrier. You can see more of what's happening. And I like to use pipes. You can also look at different flows. So like I look at the velocity measurement of it, and there we go. It is now solving, and it has now worked. And let me change the transparency, and we have now that it works. You can actually run an animation on it. And that's how I do everything. But now it's playing, maybe a little slow on zoom, but as you can see, the velocity gets quicker as the the actual portion of it gets smaller. You can come over here to these numbers. You can move them around, by the way, and you can change it to shear rate, pressure, anything you really need. Sorry.
I just said okay. Sorry, my bad.
Yeah. So this is probably my favorite part. This is actually really cool. And you can do cut plots. You can do surface plots. A cut plot is basically taking like a cut, like say we wanted just this middle part of the spiral, like a flat middle part of it. You cut it, and you can see basically the number and the colored like velocities, pressures throughout that middle cross-sectional area of the spiral. So that's just things you can play around with. I just showed you one thing. You can export numbers for graphical, entities to graph it and stuff. And yeah, so that's actually flow simulation. I told you it's pretty easy. Any questions? No. Cool. Yeah, so that's flow simulation. I am going to, on the next video, show you how to put this on preform. It'll probably take like 5 minutes, and then tomorrow sorry, not tomorrow as it is now, but in the video after that, we'll be actually printing stuff. So let me save this and stop the recording again.